Okay, so I've restarted the recording, so I'm starting over. So he gives a state assignment, which is likely that he would do on an exam for grading purposes. It makes it a lot easier to grade if everybody has the same state assignment. So we are now going to do a state assigned table. And how many flip-flops do we need? 2. And that's because there's 3. So we'll have our present state, and because it tells us to have minimal Boolean expressions for the next state, I'm actually going to give these, the flip-flops, the names, and I can never remember if y'all call the present state lowercase or uppercase. Do y'all know? Lowercase? Okay, so y1, y0. And our next state, if w equals 0 or w equals 1, will be capital Y1, capital Y0. And is this a Mealy or Moore machine? What's the definition?
It looks like it's
I think it's more.
What's the definition?
output depends on.
If the output does not depend directly on the input, it's more. And since in this table, the output, there's no w equals 0 or w equals 1. The output does not depend directly on the input, so this is more. And he said to use A is 0, 0, or what did he say? A is 0, 0, B is 1, 1. C is 1, 0. What are we missing?
1,
I got 1, 1. He said to you 0, 1. You got to put it in there because you have to account for every possibility. So I'm going to go ahead and fill in don't cares on this one. Now, when w equals 0, A goes to C, and C is 1, 0. When w equals 1, A goes to A, and A is 0, 0. And our output column is going to be the same as in our state table. When w is 0, B goes to A, and A is 0, 0. When w is 1, B goes to B, which is 1, 1. And when w is 0, C goes to B, which is 1, 1. And when w is 1, C goes to B, which is 1, 1.
Is it right to put them in the order?
It-
The Y1, Y0 in the order?
Sure. Yep. I just wanted to do it the same order as the table up here so that I could be careful, I'll make mistakes either on the step that I just did or the step I'm about to do, since they're not in the regular order. Okay, so this is the question that someone was asking me about before, about where the numbers come from on this table. So Y1, so what I look at for Y1 is I look at the Y1 column in both of these, and Y1 is going to depend on Y1, Y0. Over here, the present state, it's also going to depend on W. So this is 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1. Okay, I know when Y1, Y0 is 0, 1, I have don't care, so I'll fill those in. Now I'm going to look just at W equals 0. Just at W equals 0, that's this first column right here. And when W equals 0, that's this row of my Carnot map. So when W is 0 and little y1, little y0 are 0, 0, then my y1 is 1. Right now I'm filling in the top row up here. When y1, y0 is 1, 1, and W is 0, y1 is 0. And when y1, y0 is 1, 0, and W is 0, y1 is 1. And now for the second column, I see when it's 0, 0, it's 0, and the other two are 1, so I'm just going to fill those in.
So it would be 0, don't care, 1, 1.
Yes. Okay, now I'll do my Carnot map for y2. Why don't y'all try to do it on your own, and then you can look up and see if you get the same thing I get. So try to do it on your own and see how you do.
Wait, you switched from 0 to 2.
Oh, this should be y0. Yep. So yeah, so y'all do y0. And while you're at it, you can go ahead and do the output if you want.
You use y1 and y0.
I just use y1 and y0.
And
Was the question, how did I do output?
yes.
So it doesn't depend on W.
So you.
So it's just y1 and y0. And then, so y1, y0 is 0, 0, has output 1.
Right, I see it.
Oh, okay, 0, 0.
And then 0, 1 was don't care.
Okay, I see.
It's funny how the simple things.
Yeah, I find the 2x2 Carnot map very uncomfortable.
Yeah.
It looks funny.
But at least if you do it consistently, you can either put y1 or y0, and you can alternate it if it's the same thing. Kind of, as long as you put the rest of the stuff in the same place. The right place.
What?
So I am getting, I think the best way to cover y1 is to say that y1 is not y0 and not w, or y1 w. Oh, do y'all know what that is? No, it's not. Never mind. They're different variables. I lied. Okay. And then y0 Let's see, what's gonna be the best way to do this?
This one,
Yeah.
I think you got one of the.
Aw, which one?
1-0 for the last column
Uh-huh,
on the bottom right there. I think that should be a 1.
okay. Let's see. So 1-0, so, 1-0 and 0 should be 1, yes? Wait, 1-0 and 1, yes, 1, yeah. Yep. Oh, that's nice. Because then we can get this whole bottom row. And that.
Shouldn't just be 0 at the front?
Oh. So somebody tell me what what it should be. Wait, hold on, I need to redraw it.
Yeah, it should be
Just let me know.
Okay, I'm ready for, is this the bottom row?
Yeah.
Uh-huh,
0, don't care. 1, 1.
all right. Okay, well, that's not bad. Okay, so we get this and this, I think. So that would be, Y1, Y0, or Y1, W. And our output is going to be Y1 or Y0.
Not it. You said 1.
No. Y1 not, or Y0.
Yeah, for the next state, Y0, Y1,
Do I have another mistake? Or,
Yeah, on Y0, you just forgot to put the dot over the Y2 or Y0.
I did forget the knot. Yeah, I find the knots to be optional. It's so negative.
Wait, on Y0?
No, yeah, because I did it as Y1, Y0. Yeah.
Okay, swap it up.
Just so easy to make a mistake.
It is very easy to make a mistake. Okay, so let's go back.
I'm pretty sure we actually had a problem with that on the midterm.
You did. Mhm. Okay, I'm trying to decide what I want to do next. I think that's what I'll do next. Yeah. Yeah, we're going to do the ASM. Okay. All right, well, I gave you, there's a page on your handout that has some of the information that you need for an ASM chart. So it's an algorithmic state machine chart, special flow chart used to define digital hardware algorithms. It describes a sequence of events, so it's like as things that happen one after the other. It determines the actions that happen in the states in response to the clock pulse or in response to inputs. And ASM charts have three basic elements. You have a state box. So you have the box that is a rectangle, and it has the state name. And if it is a more, you might have the outputs on there. You have decision boxes. Decision boxes are diamonds. And you don't have to have, you don't always have to have, I don't know how to say what I'm saying. It'll come up when we do one. And then you have ovals for mealy outputs. And this will just make more sense when we do one. It makes a lot more sense when you do one. Okay, so this, first I want everybody to look at this and see if you agree that this state diagram does detect the sequence 101. Does it detect that sequence?
No.
Yes. I think it does.
Well, let's decide. Let's say I have this. This is my sequence of inputs, and I want to see if it works. Okay. So I'm going to start in state S0, and I got a 1, so I'll go to S1, and my output was 0. I got a 0, so I'll go to S2 with an output of 0. But then I got a 0 again, so I go back to S0 with an output of 0. And then I get a 0 again, and I stay in S0. And I get a 0 again, and I stay in S0. And I get a 1, and I go to S1. And I get a 0, and I go to S2. And then I get a 1, and I get an output of 1, so it detected my 101. And I go back to S1. And then my next one, I get a 0. That brings me to S2. And then I get a 1 again, and it brings me to S1. It detected my 101, so it does seem to be working. Is it mealy or more? It is mealy. Okay, so we'll start.
So we got the ovals.
We're going to have an oval. Okay, so I will call this state 0, state 1, and state 2. And then I'll have a decision. And if my the answer is 0, if I'm in state 0, I go back to this one, so that I'm checking X. Can't remember how we do this. I think I just put an X there. And then if X is 1, then I go to state 1. And then I have a decision to make. And by the way, you don't put an output if the output is 0. So we're only going to put an output on the one time that we get an output of 1. So now I have a decision to make. For X, no, I'm just saying I'm checking X right here.
Oh, okay, that makes sense.
And then if X is 0, I do one thing, and if X is 1, I do another thing. So if X is 0 from state 1,
You go to state 2.
and if X is 1,
No. Yeah, those by itself.
And this is state 2. And I'll make a decision.
So you never make a decision on the actual state.
No. And if x is 0, I go back to state 0. And if x is 1, then I have an output. I can probably just put z. I think that means z equals 1. And then from my output, after I do that, I go back to state 1. Yeah, it's really not. It looks more confusing than it is once you see how it's done. It's not as bad. Okay, so now I have an ASM chart, and we're going to see if we can do the state diagram from it.
Let me.
Were there questions before I move on?
No.
No.
To be clear, those are not used.
I know they're just here about
Wait, what now? Oh, sorry.
Whose lines are you?
Notice you don't put the output when the output is 0. Okay, so
I don't want it back.
No, this is the one that you.
Let's see, you don't want to fight.
More than me.
That's who's offering.
Roughly, it's 50 down.
That's wild.
What did you do?
Goes to 1.
Oh, it goes back to 1.
okay, so let's try this one out.
And the Z has any sort of multiplication?
No, it's just.
Alright.
And
So when he goes back to itself, it doesn't.
Oh, this is just off.
say it again?
Yeah, I'm sorry.
No? Okay, so we have M0, and is this a Mealy machine or a Moore machine? It is Moore. Oh, no, yeah, because we have an output on M3. Yeah. So we have M0, we have M1, we have M2, and we have M3. And M3 has an output of Z equal to 1, and all the others Z equals 0. Now from state M0, if X is 1, I go back, and if X is 0, I go to M1. From state M1, if X is 0, I go back, and if X is 1, I go to M2. And from M2, if X is 0, I go to M3. And if X is 1, I go back to M0. And from M3, if X is 1, I go to M2. And if X is 0, I go to M1. And I have a little pack of cookies that I'm going to give to the first person who tells me what this does.
I would assume it's count.
And what sequence does it detect?
010.
I said first.
Well, yeah, but who was the first person to say sequence detector? Man, y'all are making this hard. Let me go see what I've got. I think I have enough for everybody. If
Split it, you
Yeah.
can have like one question.
Let's split it.
Because the word
let me pause the recording.